Hey everybody, so today we are going to discuss about Floyd's Tortoise and Hare algorithm. It is used to detect cycle in a linked list, or it is also called two-pointer method. So let's see what it is. So for example, we have this linked list. So we have to tell if there is a cycle. We can see there is a cycle between 9, 5 and 7, but how can we tell it in constant space and linear time? So what we do is we take two pointers. One pointer is slow and another is fast, and we move them across the linked list. If there is a cycle, then the both pointers will definitely meet at some point because one is moving slow and other is moving fast. So that's the idea behind our algorithm. Whenever they meet at same value, we will say that there is a cycle. So let's take our two pointers. Our first pointer is hare and other is tortoise. Obviously the hare one is the fast one and the tortoise is the slow one. So we are moving our hare double the speed of the tortoise. So they move by one step. So we got the value 8 and 9. They are not equal. So we will move them forward. But value is still not equal. So now their values are equal. So we got to know that there was a cycle. How can we implement this and how can we find the value that was equal? So for implementing this, what we have to do is we have to take two pointers. One is slow, other is fast. We have to start them from the head of our linked list. Then until and unless our slow fast and next to the fast pointer is not null, we will move our slow pointer one step and the fast pointer two steps. Then we will say if they are equal, then we will apply a condition. If they are not equal at any case, then we will return null because that means that we don't have any duplicate value or we don't have any cycle. But if they are equal, then we will send slow to the head and here is at the same position at it was. Then we will move them one step at a time until they are equal because when they are equal they will be at the starting of the cycle, and when they're equal we will instantly return our slow value or the fast value because they are equal, and that's how we can find the starting of the cycle. So the time complexity of this algorithm is linear because we are iterating over the array only once, and the space complexity is constant because we are not storing anything. So let's see a question to strengthen it further. So here's our question. We have to find the duplicate numbers. In this, we have given an array and it have n plus 1 numbers and the range of the numbers is 1 to n. There is a duplicate number in the array and we have to find the duplicate number. We have also given some constraints like we must not modify the array. We have to use the constant space. We have to use the runtime less than n square, and there is only one duplicate in the array. So you must be thinking that why is this related to linked list? Because you can note that whenever we have the array that have n or n plus 1 numbers and the range of the number is also 1 to n, then it forms a linked list. So let's see how it forms a linked list. So for example, we have this array. So what we do is we say that the first value in the array is our first node of the list, and the next node will be the value that is at the index of this value, which means the value is 2. So we will see what value is there at the index 2. So the value is 9. So we will make the next node as 9. Now as our value is 9, we will see what value is there at the index 9, that is 1. So we will give our next node 1. Now our value is 1. So we will see what value is there at the index 1, and that is 5. So our next node will be 5, and that's how we will move forward. So but here when we go to the 9, our value come out to be 1. But instead of moving forward, it pointed backwards because 1 was there already. So it formed a cycle. And that's how we got a linked list with a cycle when there are duplicates. If there were no duplicates, we will get a linear linked list. So as we got this linked list, we can easily apply the algorithm we discussed. That was this. So let's implement this. So firstly, what we are taking is we are taking two variables. First is our tortoise and second is hare. As the statement is given that they definitely have a duplicate value, that's why we are running an infinite loop. And what we are doing is we are giving tortoise the value that was at the index of the previous value, which means if the tortoise is 0 initially, it will get the initial value like starting value. Then after, like if at 0 index we have 2, then the second value that tortoise will get will be the value that is at nums2. That's the exact thing we were doing when we were forming a linked list. So that's what we are doing here also. So also for the here, we are doing it 2 times because we are moving it in the double speed. And when we are finding the value equal, we got the cycle, so we break. Then, as we discussed earlier, we are sending our tortoise to the starting point and iterating over the loop until they are equal and moving them one step at a time. And when they are equal, we know that that's the value where they were duplicates, so we are returning here, or maybe the tortoise. And here's its implementation in Python. That's the exact same implementation I've done before. So I hope this is clear. This was a fun question. Try to implement this by yourself and leave your views below. Thanks for watching, and I will see you guys in the next one.